GeopByte.
Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this. A particle of mass m is driven by a machine that delivers a constant power k watts. If the particle starts from rest, the force on the particle at time t is given that constant power equal to k. You know power p equal to what? Power p equal to power p equal to f dot v. It is given as k. But what is the force according to Newton's second law? F equal to ma. F equal to m into a equal to what? dv by dt. So in the place of force, I can write m into dv by dt into v equal to a constant. From this, I can write that vdv equal to k by m into dt. Now, for getting the velocity, let us integrate it upon integration. So integral v dv equal to k constant, m constant right outside, integral dt. It is v square by 2 equal to k by m t. That is the v square by 2. Then v square into 2k by m t, or v equal to otherwise let us write in the other slide. V equal to, you got v square equal to 2k by m into t, correct na? 2k by m into t. Then v equal to what? Root over 2k by m into t. That is the velocity. Okay. Then we are asked to decide the force. Force F equal to what? Force F equal to m into a. It is equal to m into dv by dt. dv by dt. Here you got the v value. V equal to root over 2k by m into dt, into t, not dt, into t, into t. Then what is the dv by dt? dv by dt equal to d by dt root over 2k by mt. Here it can be written as root over 2k by m outside d by dt into t power 1 by 2. You simplify it. It is equal to root over 2k by m into 1 by 2, 1 by 2 into t power minus 1 by 2. So it can be written as root over 2k by this 1 by 2 I am bringing to root. It is 4m into t power minus 1 by 2. It is k by 2m into t power minus 1 by 2 outside. That is the dv by dt. Then look at the force. Therefore, force F equal to m into dv by dt. dv by dt root over k by, let me take the space, force F equal to m into dv by dt. This is the dv by dt root over k by 2m t power minus 1 by 2. You bring the m to under root, it is becoming m square k by 2m t power minus 1 by 2. 1m is cancelled. It is mk by 2 into t power minus 1 by 2. That is the force acts on the particle. Root mk by 2 into this t power of minus 1 by 2 outside the rule. Therefore, option A itself is absolutely correct. Understood clearly? It is also very, very important problem. I can say this is a 5-star problem, means this kind of problem may be repeated. Okay. Shall I take the next question? Yes. Let us take the another important question. Look at this question. Asking like this. A particle with a total energy E is moving in a potential energy region U of X. Motion of the particle is restricted to the region when. Here total energy of the moving particle means total energy equal to kinetic energy plus potential energy, because this is the total energy of the moving particle. E equal to kinetic energy half m v square plus potential energy is given as u of x. From this, E minus u of x is equal to half m v square. From this, the motion of the particle is possible. Let me read. From the above relation, from the above relation, it can be concluded that it can be concluded that the motion in the particle can be possible. The motion in the particle can be possible. Particle can be possible only when when E is greater than or equal to E is greater than or equal to u of x, or the u of x is less than or equal to E. Okay. Look at the option C. Option C is absolutely correct. Understood clearly? Yes. So the total energy must be more than potential energy to maintain the motion. Otherwise, it cannot move. Okay. Now let us take the another important question. Look at this problem. It is asking like this. One coolie takes 1 minute to raise a suitcase through a height 2 meters, but the second coolie takes 30 seconds to raise the same suitcase to the same height. Same suitcase means m1 equal to m2. Same height means h1 equal to h2. Therefore, the mgh remains constant. mgh remains constant means potential energy of the coolie 1 is equal to potential energy of the coolie 2. Then power, the power 2 coolies in the ratio. What is the ratio of power for the 2 coolies? That's what he's asking. As you know, for this particular case, power P equal to mgh by time. mgh by time. Since mgh is remaining same, power multiplied by time remains constant. Power multiplied by time remains constant means I can say that P1 T1 equal to P2 T2. Power of the coolie 1 by power of the coolie 2 equal to time taken by the second coolie divided by time. Power of the coolie 1 divided by power of the coolie 2 equal to time taken by second coolie divided by time taken by first coolie. Time taken by second coolie 30 seconds. And first coolie is taking 1 minute equal to 60 seconds. It is equal to 1 by 2. Therefore, power of the coolie 1 by power of the coolie 2 is equal to 1 by 2. It can be written as P1 is to P2 is equal to 1 is to 2. 1 is to 2. Look at the option D. Option D is absolutely correct. Understood clearly? Yes.
GeopByte.